All right, this is the 6th period video, so we'll be doing the pink highlighted questions. So, number 3. Oh, look at that. Number 3 is already done. That's okay. That was an easy one. 3 to something equals 3 to the 5th. Well, that something's got to be 5. Be careful, though. The answer is 5. The answer is not 3 to the 5. The answer is 5. Okay, so some people get confused. They know a 5 needs to be there, and then they're like, oh, it's 3 to the 5th. Like, no, the answer is 5. The reason is 3 to the 5th equals 3 to the 5th, but the answer is 5. Okay, again, we're doing like every other odd, I don't know. Number 9. Log base 7 of 7 to the 9th. I don't know what 7 to the 9th is. But if I fishhook that, I get 7 to something equals 7 to the 9th. So what do you think goes in the box? 9. So my answer is 9. My answer is not 7 to the 9. My answer is 9. Let's skip down to number 15. Let's see. Solve, and these are no calculator questions. I see a bunch of logs, so I'm thinking if I can condense down to log equals log, I can cancel the logs and set the arguments equal to each other. So let's condense the right-hand side. So the coefficients can become exponents. So the square root of 49 is 7, and the cube root of 8 is 2. And again, there's a lot of little math stuff going on in the background there, right? You have to know that a power of 1/2 is a square root. You have to be able to take the square root of 49. Hopefully you can do all that relatively quickly without having to write everything down. How can I condense the 7 and the 2? Divide. Log base 5 of 7 over 2. The other side is log base 5 of x. So even if I had no idea what logs are, I'm pretty sure that x has got to be 7/2. That's the only way this thing makes sense. So x equals 7/2. Naomi.
On the test, are there going to be questions where, like, one side has, like, log base 3 and another will have, like, log base 4?
Great question. Will there be something where it's like log base 3 of x equals log base 4 of 12 or whatever? No. Because you can't cancel the logs. Like, that's what you're kind of getting at there. You're not eligible to cancel those, and so you'd be kind of stuck. It's solvable, but not with things that we know, basically. So no, you won't have to worry about that. All right, 21. Solve for y. So I need to get y by itself. Well, there's y. I guess we could multiply by 2. That'd be an easy first step. And my y is in the exponent. How do I get an exponent to not be an exponent anymore? Natural log both sides. My anti-exponent superpowers, natural logs. So x minus 2y times natural log of e equals natural log of 2x. I could divide both sides by natural log of e. Thank you. But it would be nicer if what? Yeah, natural log of e is 1, so I don't have to worry about it. And now I've got x minus 2y equals natural log of 2x. Trying to get y by itself. So what would you do to get y by itself? I would subtract the x and divide by -2. Do I want to do that all at once? No, probably not. Maybe you do, but I don't. So subtract the x, then divide by -2, and there's my answer. And that -2 in the bottom, that negative could be used to sort of change all the signs around. So if you wanted to be sort of fancy, you could write that as x minus natural log of 2x over 2. That'd be the same thing. Let's jump down to 27. Expand. Okay, so we've got it all squished into one log. We want to expand it all out into multiple logs. So natural log cubed root x cubed minus 8 minus, right, because division is going to turn into subtraction, natural log of 4x. That's not wrong, but it's not done. So what else could I do? I think there's two more things here. I can make it 1/3, because a cube root is the same thing as a third, or a power of 1/3, so I can bring that 1/3 out front. And there's one more thing that people frequently forget to do. Somehow their brain has locked 4x together and they can't unlock to realize that those are being multiplied. So natural log of 4 plus natural log of x. I kind of like the parentheses. It sort of emphasizes that the 4 and the x go together, but then the minus sign means they're both in the bottom. If you distribute the minus sign, it's completely okay. That just sort of means that, like, separately, each of them go into the denominator. But either way is fine on whether you want the minus sign out front or whether you want to distribute it. Equally correct. $33. You know what? We need to do 32, and then we'll talk about 33. 32. Domain, range, asymptote, graph. Man, we haven't done these in a while. What's the -3 do to the graph? Down 3. So I remember that much for sure, I hope. So down 3. There's my new origin, my new starting point. So now I would like to graph y equals 2 to the x. And we didn't do many of these, and it's been a while, so there's a decent chance you're like, I don't remember what that looks like. That's fine. Just sort of rebuild the table. I guess you would have to remember what are some good x values to plug in. Yeah. And if you're not satisfied with those, you can plug in more, but those are the three, kind of the main three. 2 to the -1 is 1/2. 2 to the 0 is 1. And 2 to the first is 2. So let's plot those. I don't have to worry about the -3 because I already worried about the -3. I already took care of the down 3. So now I'm just going to plot those points from the down 3 spot. That's not wrong. It's not much, though, especially with base of 2. It didn't make a sharp turn. I'm going to go one more. If I plugged in 2, I get 4. So then I start to get a little bit sharper turn. The next one would be 8 and 16 and so on. What about the other side? This one's 1/2. What would be the next one over? 1/4, and then an 8th, and a 16th, and a 32nd, and on and on and on. And that reminds me that there's an asymptote there. So there's my 2 to the x -3 graph. Speaking of asymptotes, y equals -3. All right, we shifted the graph down 3, so I think it makes sense that the asymptote went down 3. How about domain? couple of them. And range? Good catch. What's the furthest down it goes? -3 and up. And -3 with parentheses, because there's an asymptote, we don't get there. So these things are sort of connected. Asymptote at -3, we don't get to -3. I think that's a pink highlighted thing as well to kind of emphasize that those things are related to each other. All right, 33. What's the +5 do? Left 5. 1, 2, 3, 4, 5. All right, so I took care of the 5 thing. Chances are we didn't do enough of these for you to remember exactly what a log graph looks like, but that's okay. Hopefully you remember the process of getting to what a log graph looks like. In fact, I don't like logs, so what do we do instead? Do you remember what we did on this problem to avoid having to deal with a log? Let's fishhook it. Let's see, so 3 to the y equals x. So another table of values. But what's weird, backwards, different about this table? Yeah, we're plugging things in for y. Feels weird, but I feel like a small price to pay to avoid the log stuff. So -1, 0, and 1, but in for y, which I think makes sense. If you tried to plug it in for x, you'd be stuck. There's nothing that would work for -1, nothing that would work for 0, and so hopefully you'd figure that out. Okay, 3 to the -1 is a third, 3 to the 0 is 1, 3 to the first is 3. Over 1/3, down 1. Over 1, up 0. Over 3, up 1. And again, like that previous one, if you wanted more points, pretty easy to figure out what they'd be. But this one, I think because the 3 is bigger than the 2, it makes a sharper turn, and so it's a little easier to locate what everybody's doing, or what the graph looks like. All right, asymptote, that would be x equals 5. All right, left 5, move the asymptote 5 to the left. Domain, let's move left to right. Oops, x equals -5. So I'm going to start at -5, go to infinity. I guess just be careful. I'm not starting at -5 because I don't want to include -5. It's that asymptote thing again. And then the range is all real numbers. Again, logs and exponents are inverses of each other. And generally speaking, they look like that. Obviously, that's before we move them around. All right, let's look at 39. Natural log of 1 over e. So natural log, but it's still a log, so we're still going to do the fishhook thing. What's the base of natural log? What's the unwritten? Careful, e. If it's log, it's base 10. If it's natural log, it's base e. So e to something equals 1 over e. So what goes in the box? -1. -1, and flip it over. So your answer is -1. Your answer is not e to the -1. Your answer is -1. And those are all pretty similar to that one. It's 45. Note we've switched to the with calculator part of the part of the test, or part of the review. 45. Well, this looks easy is probably too strong a word, but straightforward maybe. So maybe we get some help here. Addie, what do you want to do first on 45?
Subtract the 6.
Good. And then Naomi, what would we do after we subtracted 6?
Divide by 2.
Good. See if I can do both of those things. So minus 6 gets me 14, divided by 2 gets me 7. Two steps at once there. Kira, thoughts on what we could do next? It's not no solution. I mean, you're right to be thinking about that because you can't take the log of a negative number. But if x itself is negative, then negative negative would make it positive, so this might work. So how do I undo a natural log? Anybody? How do I undo a natural log? I could fishhook it. So Kira, what do I get if I fishhook that? Equals negative x. So x would just be negative e to the 7th. Calculator problem. Negative e to the 7th. Negative 1096.633. Remember, on the calculator problems, you're not going to have many of them. They should go pretty quick, and they're easy to check. You don't have to check them, but they're pretty easy to check. 2 natural log of negative answer. I'm just plugging my answer back into the original. Plus 6, that's supposed to equal 20. Fingers crossed, and it does, so I feel really good about that answer now. Again, you don't have to check them, but I think it'd be dumb not to, because I think you'll have time, it's easy to do, and then you'll feel good about, I know that answer's right. And if it didn't work out, well then back up and see if you can find the mistake. All right, 51. Let's see, 51. Dawson, what would you do first on 51? There's a couple of options, so if you're pondering, you've got choices here. What's that? You can divide by 4. We're going to go, yes, let's divide by 4. Show you a trick to this problem later. Whoops, divide by 4. Thinking the long way around. That's the only way we know right now, so it's not Dawson's fault. Madison, what would you do next?
I don't really know.
So, yeah, because it's like x is solved for, but I don't know how to type this in. This is kind of weird. You could fishhook this thing. That puts x to the 4th back in the, or x over 4 back in the, back as an exponent. And now how do I get it out of being an exponent? I could natural log it. If this feels a long way around, it's because it is. We'll get there in a minute. X over 4 natural log 5 equals natural log 60. So I would multiply by 4 and divide by natural log of 5 to get x by itself. 4 natural log 60 divided by natural log 5. 10.176. Man, that felt really weird. I'd like to check it, but it's hard to check because how do I do log base 5? Okay, here's the secret to this one. Your calculator can do logs with different bases. Let's back up for a second, make sure we understand what the calculator is. If I press the log button, what base is that? 10. So somebody tell me before I hit enter, what's the log of 100? 2, right? Because 10 squared equals 100, so that should be 2. Yeah. If I hit the natural log button, what base is that? E. What if I do the natural log of e to the 54? So that should be 54. Yep. Okay. So you can see why they don't make buttons for every single base, because then all you'd have is a bunch of log buttons on your calculator. But they sneak it and hide it in there. If you go to math, this is where it is on the menu. Go to the math menu. And actually, that's all you have to remember, because you can find it from there. Math, and then scroll down. See if you see something that looks maybe interesting. Log base. You press enter, and voila, it's got a little spot for you to pick your own base there. So 10 and E are common, but if you get one that's different, you can say, oh, I can do log base 5 of 60. And I was supposed to multiply that by 4. That's okay. So 4 times log base 5 of 60. Hopefully that's the same thing we got. 10.176. Hey, it is. So log base is a little cheat code that the calculator has if you know where to find it. $57. Well, that looks kind of weird. Square root of e to the x equals 4. What do you want to do first on that one? Square both sides. That'll undo the square root. So e to the x equals 16. What's that? You can natural log both sides. And the natural log of e is 1. You guys are maybe getting the hang of this and cruising a little faster now. With the calculator, it doesn't matter if you know that natural log of e is 1. You might type it in. Hopefully you know, but no big deal if not. Natural log of 16. 2.773. And again, weird problems. Hadn't seen something quite like that before. It's like, you know what? I'm going to check that because, well, honestly, because I don't have the answer key right with me. So just to make sure we did this right. Square root of e to the answer is supposed to be 4. And it is, so we got it right. Again, you don't have to check, but man, it sure makes you feel good about the answer. Let's look at 63. Ooh, log equals log. Can I cancel those logs right now? No. All right, that was almost a trick question there. What do I need to do first? All I've got to do is move that 2 out of there. Natural log of x squared. Natural log of x plus 1. So another one of those where even if you don't really know what natural logs are, pretty sure that those two things are going to have to be equal to each other for this to work. Oops. X squared equals x plus 1. So x squared minus x minus 1 equals 0. Wait a minute. That's no good. I don't think I did anything wrong. Why don't I like this problem? It's not factorable. That's okay. We can handle not factorable problems. It allows us to sing. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. 1 plus or minus square root of 1 plus 4 is 5, all over 2. Oh, I've got a calculator, so I don't figure out what that is. 1 plus square root of 5 divided by 2. I forgot to put it in parentheses, so rather than putting the parentheses back in, I just press enter and then divide by 2. So there's one of my answers. 1 minus square root of 5, I just did it again, divided by 2. Whoops. Is negative 0.618. Why can't that second work? I can't log a negative. It'd be okay over here because adding 1 would fix it, but on this side, that's no good. So mark that one out. Again, feels weird, like why am I having to do the quadratic formula? So maybe I should check this answer. 2 natural log 1.618. I'm using a rounded version now, so this may not come out exactly right. Compare that to natural log of 1.618 plus 1. Again, this is rounded, so this may not be exactly right. But yeah, the nearest, 3-4 decimals or so, those are the same. So I'm comfortable with that answer. One more of my choosing, and then you get to pick. Let's look at 69. Oh, I like this one. I can tell already. What would I do first on this one? What's that? Subtract 5. What do you want to do next? Is there no solution? You can't take the log of a negative number, but your answer can be a negative. And if you're not sure, just work it like normal and see what happens. So honestly, I thought this was not going to work because I saw the negative, but then I was like, wait a minute, this will work. What should I do next?
Can you do the exponent thing?
I can do the exponent thing. So e to the negative 2. And there's where I realized, yeah, this will work. I can do e to the negative 2. Just flips it over. So x equals e to the negative 2 plus 3. E to the negative 2 plus 3, 3.135. Will that work? This was a log problem, so I got to be careful. Yeah, that should work. Again, these weird equations, we just keep throwing all kinds of different stuff at you. But if you're not sure, check them. Answer minus 3. That's supposed to equal 3, and it does, so feel pretty good about that answer.
Cool.
I don't know if this is helpful. I'm just making this up on the spot. But if you've got a log equation and you want to turn it into an exponent equation, what do? So if you're taking this path, you got a log equation, you want to turn it into an exponent equation, you fishhook it. What if you have an exponent equation and you need to turn it into a log equation? You can natural log both sides. So that's the round and round you go there. Okay, that's it for the video portion.